Thank you, Claire. Thank you, everyone. Great to be here. Shuffle in, find a seat. So, I'm just going to tell you a little bit about what we're doing in Redfern and why, the story behind our Passivhaus journey. So, it all began 18 months ago. And where did it begin? It began right here. I was sitting on the toilet reading my HIA magazine and came across a Hampton-style house, which is not unusual, but what grabbed my attention was that this thing apparently had 10 stars. And I thought, but it's got no north-facing windows. It's got no thermal mass. What's going on? And as I read on, I thought, what is this about? And I realised that they were building to Passivhaus design principles. And I thought, what is this Passivhaus thing? I've heard about it, but I better look into it. So I started looking into Passivhaus versus passive solar. Now, I was trained in passive solar like every architect working these days, and it's a great thing. But as I looked into Passivhaus, I realised it's extremely flexible. Whereas passive solar, whilst it's powerful, if you take it out of context, the system can break down. I.e., you got no north-facing windows. It's very limited what you can do. You're relying entirely on artificial heating, and then there's no account. It doesn't take account of air tightness or all those sorts of things that people have been talking about today. So it has its weaknesses. Passivhaus is rigorously scientific. There is nowhere to hide from the realities and the post-occupancy evaluation of Passivhaus because it's built into the model, and you can't claim Passivhaus unless you've met those benchmarks. Whereas passive solar, although it's fantastic, it's susceptible to greenwash, especially if you're evil. And unfortunately, there are a lot of evil people in the property development industry. And how many times have you seen in a magazine, some design magazine, that shows a house, this is a sustainable house because it's got massive single glazing with no air sealing, but it's got 1 kilowatt of solar panels and it's got a 5,000 litre rainwater tank, so it's a sustainable house. Whereas Passivhaus, that just won't cut it, as you all know. The final thing that I decided set Passivhaus apart is the old adage that passive houses need active users. No longer applies with Passivhaus. I mean, you've got to keep the windows shut if you want to regulate the temperature. I mean, of course, you can throw them open, have your indoor-outdoor living as much as you like. As soon as it gets too hot or too cold, shut it down, and it will do the work. It's fairly automated. So I decided to apply Passivhaus to our next, at the time, upcoming property development project, which we're designing, building, developing, which we called the Fern. It's 11 one-bedroom apartments in Redfern in Sydney. So for those of you who aren't from Sydney, that's what it looks like. 7 Wyndham Street. They will be for sale at some stage. So that's the site. That's us, the red rectangle. So from a passive solar point of view, pretty bloody well. It would be fantastic, except, you know, the correct orientation, except we've got firewalls there, because apparently it's more important to be alive in a fire than to be comfortable for the rest of the time, which means that our only access to light and ventilation is through the east and west facades, which means we're constantly battling, well, in summer, battling the morning and afternoon sun. Add to that the fact that 40,000 cars drive past every day. So it's a very difficult site to create an amenable living space. So this is roughly what we are going to be addressing the street with. This is what is going to be battling the heat, the noise, and the dust of inner Sydney. But Passivhaus can take care of that, so we've been told. So what we are creating, what we are marketing, because so a little bit about the philosophy behind it. Most buildings, larger scale buildings, are procured by property developers, by finance industry people. It's the numbers that count, and they're interested in what's going to sell. They're not interested in the technicalities. Buyers are interested in what's in it for me. So what we are marketing is an oasis in the city. Everyone wants to live right in the middle of everything. No one wants to have that heat, noise and dust. And people who have lived there know that that's what you get with the current housing stock. So we're going to be promoting the fact that in here you can have a naturally lit, constant fresh air, no dryness of humidity, filtered down to allergenic levels, throw everything open, live on the balconies, close it down, it'll automatically take care of you. You're not wiping that brake dust off everything after a few days. It really is something different. And this is what our little bubble looks like as of yesterday. So what did we build it out of? I would like to say CLT, but we came across CLT just after it had all been engineered and decided that in this context it was just all too hard and would delay the project by another year. So we used concrete. We did invest in a modular steel formwork system, which has worked really well. Unfortunately, that means we'll probably have to use concrete on our next building too, so CLT might be a little way off. One of the best things about this is that, how do I do this? Play. Oh, that is a video. Okay, you'll have to imagine that moving. So that's showing the 10 panels joined together that can be lifted up by a crane. So you get these 600 wide panels and you can basically make your whole wall, lift it up with the crane, move it to the next wall, so it becomes quite an efficient building system. I told you, Lachlan, if anything can go wrong, it'll happen to me. That's all right, doesn't matter. That's right, anyway, so Lachlan's just showing you the concrete there. So we've got lovely off-form concrete feature walls in these apartments. That's all right, don't worry about it. So that's going to be a real feature of the apartments when they're finished. So breaking it down through the Passivhaus process, we had to divide the building into 2 thermal envelopes, front and rear, because it's got an open atrium, which has got lovely green walls going up 5 levels facing north, which is how we're making the most of our north-facing aspect. So we've got front and rear, which has got insulation wrapped around the outside. We have thermal bridges, because you've got to tie them together structurally, which had to be dealt with. And then in section, similar thing, that's cutting through the entry. So you've got the entry coming through to the atrium and the 2 thermal envelopes. Then down the bottom here, one other interesting factor of the site is it's near a train line and we've got serious vibration. So the whole building has to be set up on rubber blocks. So you've got 5 stories of concrete on rubber above the ground. So that means that actually gave us an opportunity to introduce thermal brakes as part of the vibration isolation system. So that's where our thermal brakes go. And we invented a new system of vibration isolation, because the conventional system is to use massive concrete column heads, which then have sort of ball and socket joints, but we didn't want to lose all the space in the basement, so we invented this system which sits inside the walls, which you can see there, which I won't go into too much because it's another topic in and of itself. But we modelled that with the therm modelling through Passivhaus. Claire Parry did all this for us and showed that if we integrate some insulation, that became our thermal brakes as well. So that killed 2 birds with that one stone. And this is the concrete basement walls being cast with those ball and socket joints essentially cast into the walls. And then our thermal brakes for the balconies, the off-the-shelf systems are designed for Northern Hemisphere climates, which makes them very effective, but in Sydney, you don't need that level of separation. We don't have -20-degree winters. So it means they're very expensive and they're really not cost viable for Sydney. So we invented one. we used what are designed as acoustic structural dowels to have a continuous structure with acoustic separation. Because they're a hardened stainless steel pin, we can use those at 900 centres in the concrete separated by a layer of XPS foam with fibre cement just as a form, and that gave us custom designed thermal breaks, which also gives us our balcony set downs, and we could do this for about a third of the price of the off-the-shelf ones, which made it cost viable. And we can now use it in every project, and I hope to get the word out there for other people, because as far as I know, no one else has done thermal breaks in Sydney. Please correct me if I'm wrong, but there's all these apartments with these big heat fins sitting out there. Every time the sun shines, I think of the balconies and all the heat that'll be transferring in, and people air conditioning to get it out. Then the cladding, the envelope of insulated envelope. Again, we invented a new system for that, structural insulated panels, which we had custom made with a tongue and groove fixing, which we can then use an insulation pin gun to fix one panel on, then slide the next one over it, and that'll hold itself on, so you get an invisible fixing wall. Which gives us our R3 insulation that we need, which again, with a passive house, it's only super insulated if you've got a super climate. R3 is not that unusual, it's more than usual, but it's not that hard to achieve. And then when we've got corners inside in our atriums, we've introduced a nice timber routed piece to bring a bit of tactility to the design. And that's what it's starting to look like on a balcony. And that is framing a window, which takes me to the next topic, our doors and windows. Triple glazed, we're using a less efficient system. You cannot get the U value that we need, which is only about 1.4 through double glazing. We used an older, cheaper system, which needs triple, but that also helps us with our sound. So we've got aluminium clad timber framed windows, the tilt and turn style, and lovely big lift and slide doors. So the balconies, you can get that sort of 2 metre wide opening to have your inside-outside living. The lift and slide mechanism means that the 200 kilo panel can just push along and slide and close beautifully, and when it drops onto those seals, it will be perfectly quiet and dust-free when people are living there. Then we've got, of course, our HRV systems, which have been mounted. We've jammed them all into the bathrooms. The plumbers hate me on this job. They keep asking us and say, so where are you going to put this then, huh? That's going to be a good one, isn't it? And just in case you're wondering, yes, I know that pipe doesn't go in there. So there was another challenge with the HRV, and I showed you this because this is what we've actually worked off. This is kind of the final solution after a number of different queries. So because of the noise, we can't have on the right of the screen is Wyndham Street with the 40,000 cars. We can't have any penetrations in the facade on the front or two sides of that wing for acoustics, so everything has to come out the back. And on the back, we've always got the firewalls on the side, so it's very constrained as to where we can actually put our inlets and outlets for the HRV. So it's been a bit of a Tetris game like the rest of the project. But all the HRV systems sit in the bathroom ceilings, and we've managed to jam all the exhausts and supply and exhausts. And then I won't go through every level, but the top level, that's the 4 bathrooms gathered around the top of the lift shaft, which we've turned into an open air plant room for our hot water, all that sort of stuff. And we've got all them jammed around there with the supply and exhaust going out over the lift, and the internal piping coming through and worming its way down through the building. So that's what it looks like again as of yesterday. It's a lot of veins running through this building. A few more of the veins are the electrical system, which is worth mentioning quickly. This is the diagram we drew at the final meeting working out how it was going to work. We're having an embedded private network, because that's the only way to individually meter hot water. And this would be a whole other half-hour talk about all the solar. Basically, we're divvying up all the solar between everyone, building individually, etc. So we've got a check meter on the main meter. We've got then a switch which takes it out to 4 3-phase meters, smart meters, which are being used as single-phase meters to meter each different apartment, and then they take Each of those has 2 pulse inputs, so we're having hot water meters for each apartment which feed a pulse input into the smart meters, and then there'll be a smart meter on the PV if we have battery backup, which we're doing the viability on that at the moment. Battery backup will feed into the solar, and that will then all talk to the smart meters. Will all be managed off-site through a software program in the cloud, automatically billed. Strata doesn't have to do anything, we're hoping to get as close as possible to net zero energy, but remains to be seen. But what that does mean is that everything will be accurately billed automatically for the rest of the building life, or for the building life. And we went out to market and got an offer from an embedded network manager. And what that came down to is the annual cost, the upfront cost for us as developers is only $2,000, which is attractive. Annual cost for owners $3,000, 50-year owner cost $152,000. And that's all the billing, and that would be instead of your network access fees and all that sort of thing. So the way we're doing it, which is the private network, which we're essentially managing ourselves through this software, is costing us more up front, but going to only cost $1,800 a year to do all the billing, automate all that, and over 50 years, $90,000, which is, again, a lot cheaper than your conventional service. So then what is all this going to look like and feel like when it's done? Hopefully a little something like this. So this is our draft interior renderings showing we've got oak herringbone floor with a whitewash to bounce lots of light through the apartment. Timber veneer joinery. The joinery here, the interior is really conceived as a piece of furniture wrapping around the space. Everything's tucked away but easily accessible. And there's our off-form concrete walls with cast-in gypsum wall lights, which give it a lovely sort of soft, natural feel. So all the conduits were cast into the concrete. There's those big lift and slide doors opening out onto the balconies. And then the balconies are really sized to be outdoor living areas of themselves, with planter boxes going right across the facades to give a bit of a kind of more of a sensual buffer from the street and the public domain. There will be automated Venetians on timers that come down on the outside of the balcony to keep that heat load off the triple glazed windows, because it's surprising how much heat even comes through a high performing window if the direct sun's on it. Bathrooms, nice, put a lot of effort into the detailing to try and create a bit of an uplifting space, and bedrooms with, again, feature walls in the bedrooms and curtains, everything kind of integrated with those high-performing European windows. So really trying to create an appealing, so that there's no compromises for people to live this. We're trying to make it so it's positives on top of what they would otherwise be looking for. We don't say, oh, you can move here, but you have to live with this. It's like everything you wanted plus more is what we are going for. So the real point of this is to try and, one, show buyers what's actually possible, that if conventional developers who really just care about how quickly they can do it, how much money they can make, if they started thinking more about the product, what they could actually achieve. And two, show the developers that this can actually be done in a speculative development business model, because it has to make a profit. For this to work, it has to make a profit, because it's only going to propagate naturally if it makes a profit. And that's when other developers are going to say, hey, we've got to start doing that. Because at the moment, developers are, and if developers, they are reactive to market demand. So if you went to a developer and said, hey, I know how to save you money on your next job, laminate bench tops, Westinghouse appliances, and one batten light in the middle of the living room. No one's going to buy that. What are you talking about? So they will respond to market demand. They're saying they need European appliances, stone bench tops, and recessed downlights, even though it costs more. That's what they're demanding. So our dream is that developers are saying, I want to see double glazing, I want to see solar panels, and I want to see HRV in this thing, because that's what people want these days. And once the buyers start asking for that, once more people are doing it, the economies of scale start working. Once all those incremental hurdles are overcome, hopefully will have a chance of living to the next century. Thank you very much.